Hi everybody, so we're on our day 3 of position, velocity, and acceleration notes, and today we're introducing two new ideas. So the first big idea is we need to look at sometimes when we are moving towards or away from the origin. What this means is that because most of the time our particles are moving along a number line, the origin is always 0. So we want to basically know, is our particle moving towards the 0 or is our particle moving away from the 0? Now we could be heading towards 0 from the right or from the left, and we could be heading away from 0 from the right or from the left. So it really matters that we look at two pieces of information. We need to look at both the position of the particle and the velocity of the particle. And once we figure out that information, we're going to go ahead and make a number line picture to kind of visualize what's happening to help us answer the question. In order to figure out when we're furthest from the origin, we need the highest position. Now this could be the highest position to the right or the highest position to the left. So in other words, we want the maximum or the minimum. Now one thing we know is that when we look at a graph, our maximums and our minimums are easy to find because they're the peaks and the valleys. And the way that we're going to do that when we're thinking about it in terms of derivatives is we're going to know that when you reach a maximum or when you reach a minimum, the slope is always 0 at those points because that is a turning point of the graph. So we're going to leverage that in our favor. In order to figure out where we have a maximum or minimum, we're going to take the derivative of position. In other words, we need to find velocity, which means if you already have velocity, you can skip that step. Then you're going to set that derivative equal to 0. And the reason we're setting it equal to 0 is we know that maximums and minimums occur on a graph at places where the slope, or in other words, the derivative, is equal to 0. Finally, we're going to make an options chart. So of all of the maximums and minimums, which one really is the biggest or the smallest? And then we're going to find the y values and the endpoint values to figure out which one is actually the biggest. The reason we include the endpoint values is that sometimes when a graph stops, it causes a maximum to happen. As opposed to when you have an arrow and it keeps going, you can't get a maximum or a minimum if you don't actually stop anywhere. So including the endpoints is another way to get maximums or minimums, even though the derivative isn't 0 there. So let's see. We've got a particle that's moving along a line so that its position is always given by this function. So at t equals 4, we want to know if the particle is moving towards or away from the origin and justify our answer. In order to figure out whether the particle is moving towards or away from the origin, we need to know where we are now and what direction we're going in. So we're going to need to know the position at 4 to figure out where we are now. The position at 4 would be 4 squared minus 3 times 4 plus 1, which would be 16 minus 12 plus 1, which is 5. Then we're also going to need to know our velocity. So I'm going to start by taking the derivative of my function, which is 2t minus 3, and then I'm going to plug in the number 4, which would be 8 minus 3, which is 5. After I do that, I tend to just sketch a picture to figure this out. So if I imagine a number line, if I'm standing on the 5 and my velocity is 5, which means it's positive, then I'm moving to the right. So based on that picture, I'm going to be going away from 0. So I would say the particle is moving away from the origin because the position at 4 is positive and the velocity at 4 is also positive. We're going to go ahead and save the next two for when I see you in class. And well, actually, we'll save the next one for when I see you in class, and we'll do number 3 together right now. This one says, when is the particle the farthest from the origin? Farthest from the origin means I'm going to be looking for a maximum or a minimum, which are places where the slope of the graph is 0. So I would start by taking the derivative. In other words, I would find my velocity function, which is 2t minus 3. And then I would set that equal to 0, because maximums and minimums occur at places where the derivative is equal to 0. So I would have 2t equals 3, which means t equals 3 over 2. That means that the point where t is 3 over 2 is one of the places where I could have a highest or lowest point on the graph. Now the other places where I could have a highest or lowest point on the graph would be the end points that are in my interval here. So what I'm going to do is make an options chart. I'm going to make a list of all of my t values and all of my positions, and I'm going to use that to figure out who's actually farthest away. So the first t value is 0. The next t value would be 3 over 2, which is 1.5 for those of us who are more comfortable with decimals. And my last t value would be 2. In order to find the y values, I'm just going to take those and plug them into my function, which is going to give me 1. For this one, I'm going to get 1.5 squared minus 3 times 1.5 plus 1. I can't do that in my head, so I'm just going to go ahead and write it out. So it's 2.25 minus 3 times 1.5 would be 4.5 plus 1, which is 3.25 minus 4.25, so negative 1.25. And last but not least, if I plug in the number 2, I have 2 squared minus 3 times 2 plus 1, which is 4 minus 6 plus 1, so negative 1. Of these numbers, the one that is farthest from 0 is 1.25. So I would say the particle is farthest from the origin at t equals negative 1.2. At t equals 1.5. I almost listed the y value there. 1.5 seconds. Okay, that's it. Thank you guys so much for watching. Have a wonderful afternoon. I'll see you for some practice tomorrow.